Hello guys, this is Lazy Admin and welcome back to my YouTube channel. In today's video, we are going to talk about virtualization as a concept and we are going to touch one of its flavor, that is KVM. To start, first, before starting this video, I'm kind of a big fan of open source technologies. I would love to deploy open source virtualization hosts and firewalls. I would love to play around with the open source technologies because there is no licensing terms that is required. So and with a little bit of customization, it can run equally as good as the enterprise level softwares out there. So let's get started with virtualization. Well, guys, virtualization came into picture around 1999. Before virtualization, our traditional hardware or our traditional OS would look like this. We have a hardware that can be any physical server. On top of that server, we install operating system that can be Linux, Windows, anything, Mac OS, anything. So on top of these operating systems, we are running applications, could be web server, could be file server, anything. So actually down there, the hardware is like, let's say the hardware is like a very big powerful server, and on top of that we are deploying only an operating system that is utilizing all the resources. It is not, I cannot say it is utilizing all the resources, but it has like taken over all the resources of the underneath system, even though at a given time it is utilizing like 2% of the entire resources that are located in this hardware down there. So it was quite inefficient and it was not cost effective at all. So if I need another application or that I want to segregate, I would buy another hardware and I will install another operating system and then application on top of it. So it will increase electricity cost. It will increase my space because I have to mount that server somewhere in the data center, so on. So from there it came the concept of virtualization, what virtualization actually is. So we have the same hardware that is a powerful server. On top of that powerful server, we are not installing the operating system now. So what we are doing now, we are not installing operating system, we are installing a layer. This is where all the magic happens. This layer is called virtualization layer or a hypervisor. Hypervisors like Hyper-V in case of Microsoft, Citrix, Zen Server, KVM. So VMware is ESXi. So it can be any hypervisor. The hypervisor actually utilizes the underlying hardware with 100% accuracy actually. So what happens is now I can create my OS or applications on top of this virtualization layer, and this is called my virtual machine. So guys, what is actually a virtual machine? A virtual machine typically utilizes the host physical hardware like CPU, disk IO, and network adapters. The hypervisor, the layer between physical and virtual spheres, is the foundational core of every virtual infrastructure. It manages the hardware resources of the host machine, and it is the responsibility to distribute them efficiently among different virtual machines. So basically this virtualization layer is actually utilizing the underlying hardware efficiently and making a connection of different virtual machines with the hardware. So irrespective, here comes another thing, irrespective of what is the physical hardware down there, virtual machine is quite flexible. Means if the underlying hardware is changed, and the virtual machine still can exist because it does not know what the underlying hardware. Only this virtualization layer is telling me that down there is this much CPU, this much RAM, and this much hard drive. So So it makes the virtual machines quite flexible. So plus it makes the hardware cost effective. The solution is cost effective now. Now I can have a one powerful server and I can run tens, twenties or hundred of virtual machines in today's world. So this is how the traditional architecture looks like. So now let's drift away and talk about the current today's world most popular hypervisors out there. So talking about this, VMware, Hyper-V from Microsoft, KVM from Linux. Actually, Red Hat is the Red Hat is developing this KVM stuff. So all these hypervisors actually achieving the same thing with a little to minor differences. They are achieving the same thing, same goal, virtualizing the underlying hardware, and on top of that you can run your own virtual machines, you can run your containers, and today's world you can run your containers as well. So here I have displayed a picture where you can see the uh, with a little difference of how the hypervisors architecture looks like. So on my left hand side is the KVM architecture. You can see it has written bare metal. Bare metal server means we have a physical hardware. On top of that physical hardware, we are deploying a Linux host kernel. The host kernel has hypervisor in it, and on hypervisor, the guest virtual machines are running. So we still have host OS in here. So let's go to the VMware side. VMware also does the same thing. Uh, it takes the underlying hardware, and on top of that, it deploys its own layer called virtualization layer, that is ESXi. And on top of that, we have our virtual machines, different virtual machines like here Windows 2000, NT, Linux, like this. So this is also a bare metal. It has its own customized operating system that is called ESXi. While in KVM, we are using Linux kernel. We are installing a Linux operating system. On the rightmost, there is a simplified Zen server architecture diagram. As you can see, Zen down there, it's a hardware. On top of that, there is a Zen hypervisor. And on Zen hypervisor, you are running guest OSs. You can see here. So basically, all of them achieving the same thing with little to no differences. So that we are interested, today's video, we are more interested in KVM. Let's talk a little about what KVM actually is. So guys, it's called kernel-based virtual machine. KVM is a virtualization module in the Linux kernel. As I've already told you that on top of that hardware, we are actually installing a Linux OS. In the Linux OS, we have KVM functionality, some packages that can run KVM, that can virtualize the underlying hardware. So this kernel to function as a hypervisor. So Linux kernel will act as a hypervisor. There are many platforms that we can use to deploy virtual machines while using KVM. I have some my favorites that I use. I prefer. I use that one is Virtual Machine Manager. I mostly I use this one. So there are other alternatives also like Kimchi, Mist, uh, OpenQRM, genome boxes, overt. So all these uh, all these open source what you call managers to uh, uh, to uh, to easily acquire the functionality of KVM, to use the functionality of KVM. While in VMware we use vCenter appliance or vCenter server that actually controls the entire vCenter or ESXi hosts or the virtualization host, so we can deploy and run virtualization. So in my experience, I have worked on almost VMware, Hyper-V, KVM, Oracle Virtualization, Zen, Citrix. So honestly speaking, all of them achieves the same goal with little to no differences. It's only about uh, VMware will look all shiny because you are paying a lot of money behind. You are paying a lot of money for the licenses, plus the company is developing a very good front end GUI kind of a thing. While open source, on the other hand, will not give you that much shiny options, but it can achieve all that what VMware can, but you have to customize it according to your needs. So so folks, we already have one CentOS 8 virtual machine prepared, and now we are going to install kvm packages in here. So let's start with kvm packages. But before we proceed, let me check one thing. Okay, so this is the IP we have, and the adapter name is ENS33. I may be a little old fashioned. I don't like the way they name the Ethernet adapters right now. So I like the way H0, H1, H2 like that. So I will show you the way how you can actually change this. You have to make a little change in the grub and remake the grub and restart the virtual machine. So let's do that. So we will do some changes in grub. So this is the line here. We need to add just a few things that I will show you just now. Here we will add net.ifnames is equals to 0. So my adapters should start naming from 0 at 0 at 1 at 2 like that. So this is all. I will save and quit. Now the grub configuration has been saved, but we have to remake the grub configuration. So we'll do grub to -make config. Okay, let me just redo the command. Yeah, I had some typo error in here. So the configuration of the grub is done. Now we will go to network scripts, our network adapters. The network adapter name is ifcfg ENS33. So we will rename it ENS33 to CFG H0. And we will change few things in here. So as you can see, the name is H0 and device name is H0. The rest is all fine. IPv6 is disabled and I have dhcp running. So that's all. So what I will do is I will just do a reboot for this configuration to take in effect. So I will reboot the OS. So as you can see now that our interface cards are renamed like H0. The next interface card will be H1, H2 and so on. Consider me a little old school, but I like the way it is named like this rather than the ENS or ESP like that. So now let's start with installing the binaries for what you call it. Before creating binaries, let me show you a little. Let me tell you one small thing. When you are making a virtual machine in VMware or VirtualBox, you can select bridge adapter. Bridge adapter does what? It connects, it bridges the interface card of the VM virtual machine with the interface card of your physical machine. So let's make a bridge adapter here so we can utilize it. So let's do that. We are at which location? Root slash network scripts. Here we will create a bridge adapter. So I will do vi. Vi is actually a file editor. If there is no file there, it will create that file. So vi if cfg br0. So this is our bridge adapter that we are going to make. So now I will copy a little bit of configuration in here. This is as per the configuration of my network. So it's a bridge adapter device BR0, and here I have mentioned the IP and the network on my bridge adapter. So we'll save and quit, and the bridge adapter is created. Now we have to add this adapter in our Ethernet card also in our Ethernet settings. So vi slash vi fcfg at 0, and here we will add the bridge that we have recently created. So bridge is br0. So I will save and quit. So bridge is also added now. So that's all. That's it, folks. So now we can move towards creating installing binaries for kvm. So the command in the new CentOS 8 has changed from yum to dnf. So dnf install qemu-kvm, qemu-img, libvirt, and all this. So I will hit enter. So yes, please install all these binaries for me. Okay, these are 47 packages, so it will be installed. Yes, I want to install these packages. Okay, all the packages are now installed. So let's check if the KVM is running. No, the KVM is not yet running. So remember from my old videos that you can enable the configuration systemctl enable any service that you want to keep in with the OS. When it reboots, it loads with the OS like the service you want to enable. In Windows, you make the service automatic start. So if you want the service to automatic start, system enable, and then we will follow up with the name of the service, that is here libvirt, and same command. And if we want to start it, start, and the same command if we want to check the status. So you can see here now the kvm is running on our virtual machine. And now, as I have discussed in the start of the video, there are many like vCenter. There KVM has many management centers available. So I will be using virt-manager, virtual manager. So I will run virt-manager. It cannot find the package, so it asks me, do you want to install the package? Yes, I want to install the package. So yes. So basically you can use this package, and you and in GUI you can like you are using VirtualBox or VMware or Hyper-V. In GUI you can make a virtual machine. So the package is installed. So we will head back to our GUI of this CentOS machine and run this virtual manager. So folks, we are going to create a new virtual machine in here. So I will click here, create a new virtual machine. Yes, obviously we'll do a local install. We'll select an ISO that I've already copied on this CentOS machine. Browse and browse local. My ISO is located in home downloads. So let's head to home, user one, and downloads. I have copied my Windows Server 2012 around here. So I will double click this one. So waiting for install media/source. It has to detect the operating system. Yeah, it has selected the operating system as server 2012. Hit next. Give it 1 gig RAM, 1 CPU. It's all okay with me. I don't have enough space. It shows I will give it, let's say, 10 gigs and hit next. Okay, this is for lab sake. Obviously, you will not give a 10G. You can still customize before install and select network right away. So we'll hit finish. That's it. We have created our virtual machine. So allow, yes. And the virtual machine is created. As soon as it is created, it will power on. So as you can see here, the virtual machine is powered on state. We can shut it down and do other things. So just wait a bit since I am running KVM inside a virtual machine. So it is expected to be a little slower right now. But honestly speaking, guys, in a production environment where you have a good hardware, this works as good as any other enterprise level virtualization solution. So go give it a try. This is uh, for free of cost, open source, and easy to manage. And you can deploy in runtime and you can create virtual machines. So since it is developed by Red Hat, mostly developed by Red Hat, so you will not expect a lot of bugs coming around. You will get frequent updates or patch releases. So please give it a try and you definitely will like this solution. So that's it, folks, for the KVM. And thank you for watching my video. If you have any questions, please do let me know in the comment section. Uh, and please support my YouTube channel and do hit like and subscribe button. Thank you, folks.